Okay, so to do our simulation, we are using Comsol Multiphysic 5.0. Okay, so first we add study, stationary, and then we add physics, non-isothermal flow. Here you can see here. So then we add geometry. First we add the big triangle. Here this one, the big triangle, according to the coordinates. We start from 0 and 0. And then we add 4 circles with the same radius. And then we need to do the rectangular here according to the y given. Each student has different y value and also different x value from this circle to the end of rectangular here. And then we need to add 2 square below here and over here. And then we need to subtract all the 4 circles here from the rectangle, and we have the final geometry exactly like this. And then we add material. The material will be water to all the domains. After adding the material, we do the non-isothermal flow. So first we start with inlet. This is the inlet, and we set the velocity of 0.11. It is given in the question. After setting the velocity, we set the temperature for inlet, which is 298 Kelvin. After setting the inlet 1 velocity and temperature in the inlet, we set the boundaries for outlet 1, which is here. After setting the boundaries for the outlet, we go to the heat flux. Here we need to change the heat transfer coefficient until we get the outlet temperature of what is given to us, which is
111.
So the heat transfer coefficient that we obtain is different from each other because our geometry is not the same due to the difference of y value and x value. Next, we will have to add mesh to our geometry, and we get the result like this.
After building the mesh, we will have to compute to get the results. Then we will have to plot the groups according to the questions given. First, the question requires us to build an isosurface with a temperature gradient. Here we can observe it here. Second is you have to build an isosurface also, but then we have to make it a contour, but then again according to the temperature. This is also the contour temperature but in a different color. Then we will have to build a contour according to the velocity magnitude. Next, surface temperature with a streamline velocity field. Also, we have to plot the temperature distribution. This is the results that we got.
So we took the value from our console and we plot it in Excel. And this is the graph of heat transfer coefficient and average outlet of T2. So we can see as the heat transfer coefficient increases, the average outlet of T2 also increases. And we also plot the optimum chart, which is our trial and error process to determine the heat transfer coefficient. And we can see the optimum point is around 71.5. which at this point we get the temperature outlet of 111 degrees Celsius.